Hi grade 9s, welcome to another one of our video lessons. So today we're going to continue with topic 11, Pythagoras. So from last week I asked you guys to do the revision section. So this week during our Skype lesson I want to go through that, or rather at least address some of the questions that you might have had on that. But today we're going to carry on with the theorem of Pythagoras. Okay, so I'll explain how it works and how do we prove it. And then we'll use the theorem of Pythagoras in right-angled triangles to prove certain things. Okay, so let's first start with what the Pythagoras is actually saying. So he's saying that we have a right-angled triangle. Okay, so let's say I draw my right-angled triangle like that. Okay, no, not like that. We'll try again. So let's go like that, and like that. Okay, so here's our right angle triangle. Right angle, remember, is denoted by this symbol over here. And let's give this triangle values. Okay, so in the diagram they call it A, B, and C. Okay, so A, B, and C. So let me just give you a little recap on naming things. Okay, so let's say we have a triangle that looks like this. Okay, and we have angle A, angle B, and angle C. Okay, so we have triangle A, B, C. These are points. Okay, so if we have this point C over here, the opposite side, this AB, it can be called AB, or it can be called little c. Okay, so usually the big letter denotes a point, and then across that we can call that side little c. So if this is our big A, we can call this side little a, and if this is B, we can call this side little b. Okay, so now in this diagram, AB can be denoted as a side, and that also equals to C. Okay, so we can say AB is the same size as the side C. All right, so I hope I'm not confusing everyone, but yeah, it's just naming points. Okay, so that's what they're doing here. So in this diagram, they have big A over there, and the opposite side is A. Small c here, therefore this is a big C, and B, that's the opposite angle, that's the big C. So we have triangle ABC, and the sides are A, little c, and little b. Okay. So Pythagoras is saying that if we take this side over here and this side over here, so A and we square it, plus B and we square it, that will equal to the biggest side, which is known as the hypotenuse, C squared. Okay, this is the result that Pythagoras has stumbled upon or proved it or found. Okay, so when we have a right angle triangle, this side squared plus that side squared equals to this side squared. Okay. Now, there's an interesting way that we can actually prove this graphically. So I'm going to rub this out. And what I'm going to do is I'm going to give these values. Okay, so I'm going to call this 3. I'm going to call this a 4. And I'm going to call this a 5. So 3, 4, and 5 are just the distances of this triangle. Okay. Now remember, Pythagoras said that 3 squared plus 4 squared must equal to 5 squared. Okay. Well, let's check if that is actually true. Well, 3 squared, what I'm going to do is I'm going to draw a block like this. So that's 3 and that's 3. 3 times 3 gives us 9, which is 3 squared. So what I'm going to do is I'm going to divide this into 9 blocks like that. Okay, do you see that? So 3 times 3, which is a squared, 3 squared, is 9 blocks. Okay, cool. We can do the same thing with a 4 over here. So I'm going to draw a square. And remember, we call it squaring because we're multiplying it by the same thing. And the sides of a square are the same. So that's where it comes from. Okay, so we have 4 over here. So what I'm going to do is I'm going to divide this into 4, like that, and divide that into 4, like that. Okay. Right, so that's what we have. Now, for this side, I'm going to do the same. I'm going to make this into 5. Okay, I'm a little bit running out of space, but we do the same thing. Okay, so that's 5. Okay, so if you're asking, what have I just done? Okay, what I've done is I've extended each side of this triangle into another side, where we multiply 3 by 3, and we are counting the number of squares essentially, okay? Because 3 squared is 1, 2, 3 times 1, 2, 3, which is 9. 4 squared is 4 times 4, which is 16. And 5 squared is 5 times 5, which is 25 blocks. So what do we actually have here? We have 9 plus 16 equaling 9 plus 16 is 25, and it's also the same 25 over here. Do you see that? Okay, so we've kind of proved it graphically that yes, it does work. Okay, but this is only true if we have a right angle triangle, and not all right angle triangles can be work so easily like 3, 4, and 5. This was just a particular numbers that happen to work very nicely like this. Okay, but what I'm trying to say is that if we have any right angle triangle, we can always find the missing side if we have 2 sides and we know that it's a right angle. All right, we're going to use that information now to start solving for the missing side. Okay, one is to find the hypotenuse, and then going backwards, if we have the hypotenuse, what is the other side? Okay, so I'm going to take this off and we're going to get into an exercise. Okay, so what I want you to look at is the worked example on page 99. Okay, so it says 1, calculate the value of x giving reasons, state the perimeter of triangle ABC, calculate the area of triangle ABC. All right, so first let's look at the triangle that they're giving us. They give us a right angle triangle with sides 8 and 15. Okay, so here's our triangle. We have sides 8 centimeters and 15 centimeters. Okay, and we are asked to find the hypotenuse, which is denoted as x, and we have triangle ABC. So ABC. Guys, if you are required to draw a diagram for me, I need it to be fully labeled. Okay, right, so that's what they give us. They say, right, first calculate the value of x giving all the reasons. Okay, so there's our value of x. They told us it's a right angle triangle, so that means we can use the result of Pythagoras. That's going to hold. So Pythagoras says that this side times that side equals the longest side squared. Okay, so 8 squared plus 15 squared must equal to x squared. See, there's our equation. And now all we're going to do is we're going to try to solve this for x. Right? Numbers to one side, x's to the other. That's what we already have. So we can simplify this. So 8 squared is going to be 64 plus 15 squared is 225, which equals x squared. 64 plus 225 is going to be 289. So 289 equals to x squared. Okay, 289 is, I believe, is a 17. So what I mean by that is, remember, we want an x. We don't want an x squared. How do we get rid of an x squared? Remember, exponents and the root signs are opposite operations. So if we want to get rid of an exponent, we need to root that exponent. Okay, so to get rid of this x squared, to get into an x, we square root that side. But whatever we do to the right, we must do to the left. Okay, so that's what it will become. Root of x squared, the square cancels with the root over here, so this will just give us an x, and I'm going to flip them around. So x is going to be, root of 289 is going to be 17 from what I believe. Let's quickly check that. Just quickly use my calculator on my PC. No, that's calendar. Yes, 17 times 17 is 289. Okay. Right, so using the theorem of Pythagoras, we've got our equation, we solved, and we got x to be 17 centimeters. Okay, and that is our answer there for part A. Right, then number 2, state the perimeter of ABC. Okay, so perimeter of ABC equals, remember perimeter is all the sides of the triangle added together. We are taking a run around the triangle or a block, and we want to know how much is that. So 8 plus 15 is going to give us 23. 23 plus 17 is going to give us 40. So the perimeter is 40 centimeters. Remember, perimeter is not square units, it's normal units because we are walking around the block. We're not multiplying to get area. Now the next question says calculate the area of triangle ABC. So now area equals, what's the formula? It's a half base times height. Remember, it's perpendicular height to the base that we are using. So if I have my right angle triangle, if my base is here, my height has to be perpendicular to it. It can't be the hypotenuse because this angle is not perpendicular. It's not 90. So that's a 90-degree angle. So here we have our base. That's our perpendicular height. And then across we have a hypotenuse. Okay. So to work out area, it's going to be a half multiplied by base. We can use this as base, which is 8, multiplied perpendicular height, 15, equals a half times 8, or 8 divided by 2 is 4. 4 times 15 is going to be 60. Now, what are the units that we are using here? It's centimeters times centimeters, which is centimeters squared. We're working with area. All right, so that is 60 centimeters squared. All right, so that is the first worked example. And then the second worked example is now going a little bit backwards. Okay, so instead of now working out the hypotenuse, I give you the hypotenuse and I ask you for one of the other sides. So let's quickly do this one, and that should enable you to do this massive exercise 11.1, which I know you're all very happy about. So yeah. Okay, cool. So let's do that other example. Right, it says calculate the value of y giving reasons. Okay, so the one thing we didn't do, remember this is still a geometry section, so when we stated our equation from the question before, what it was? It was 8 squared plus 15 squared. So 8 squared plus 15 squared equals x squared. So remember we just did this. At that first step, we should have wrote the reason why we're saying that, and it says Pythagoras. Okay, so you can just write Pythagoras. Okay, that is our reason. Sorry, I forgot about that. So Pythagoras is your reason. Okay, cool. So let's go to the next triangle. So it gives us a right angle triangle that looks like that. And we have y 20 and 29. Okay, it's a right angle, EDF. Okay. Right, that is what we have, and it's also in centimeters, centimeters, and centimeters. Right. So now the trick is don't just put the formula in, don't just put values in. You must understand that it's the hypotenuse squared, the longest side equals the two shorter sides squared. Okay, so we need to fit this info onto that. Remember, our longest side squared, which is now 29 squared, must equal to the two shorter sides. Okay, so this will be y squared plus 20 squared. Okay, so that's what we have. So the unknown is now on the right-hand side rather than the left. Okay, it's mixed up with the numbers. So it doesn't really change anything. All we have to do is just take numbers to one side, multiply these out, and square root both sides like we did in the previous example. Right, 29 squared. Okay, so this is where we can go the long way, multiply it out, or we can use a calculator. So I'm going to use a calculator quickly. 29 times 29 will give me 841. So 841 must equal to y squared plus 20 times 20 is 400. 2 times 2 is 4, plus we're adding 2 zeros, so that will be the 200. Okay. Right, so we're going to take this 400 to the other side. So we'll do that. So we have y squared equals, guys, I'm flipping it around. I'm not taking it to the other side, this y squared. I'm just flipping it. So this 400 will come here, and the y squared will equal to whatever we have here. What did we have here? It's 841 minus 400 equals 441, which is y squared. So y squared is 441. Remember, we wanted y, so we're going to square root both sides, and y is going to be root of 441. 441. Interesting. Let's see what we can get. Maybe it's 21 times 21. Let's see. 21 times 21. 441. Okay, so the answer here is 21 centimeters. Okay, so this one of the shorter sides is 21 centimeters. Okay, so from these two examples, you can see the two ways we can ask for Pythagoras. Okay, again, I forgot the reason here. It's Pythagoras. Okay. Right, so then number 2, state the perimeter of triangle DEF. Okay, well, the perimeter is add the three sides together. We got y to be 21, so it's 21 plus 29 is 50, plus 20, it's 70 centimeters, like what they have. And, or rather, meters. Sorry, we're working in meters here. Okay. And then calculate the area of triangle DEF. Okay, the same thing with perpendicular height. So remember, we cannot use the hypotenuse because this angle is not 90 degrees. This angle is 90. So the two sides we are using are those. So our area A, or area, equals a half times base times height. Our base is 21 times height, which is 20. Okay. And that equals a half of 20 is 10. 10 times 21 is 210 meters squared. Okay. Right, guys, that is page 99. That takes us to page 100. Okay. Let's quickly look at some reminders about roots and how they work. So a few reminders about squares and square roots. Okay. The main point here is that you need to treat whatever is under the square root, treat it as brackets. Okay, so what we're trying to say here is this. So if we have something like this, 3 squared plus 4 squared. Okay, root of 3 squared plus 4 squared. The correct way to do this is to treat whatever is under the root sign as brackets. So work this out first and then take the root of it. So this would equal to the root. Do this first. 3 squared is 9 plus 4 squared is 16, which equals to the root of 9 plus 16 is 25. And then the root of 25 is 5. Okay. The incorrect way to do this is to say, well, the root of this equals to, oh, that root cancels with that, so it's a 3, and that root cancels, or that exponent cancels with that, and it's a 4, and the answer is 7. No, the answer is not 7, the answer is 5. So keep whatever is under the root sign as brackets. Okay, so in fact that does not equal to that. Okay, this is the correct method. Okay, so just revise on those rules. Just have a look at that, so you're not making those silly mistakes. And we are moving on to exercise 11.1. So let me quickly go through it. So fully simplify each of the following expressions without using a calculator. Okay, guys, that's just some revision for exponents and root signs. We did plenty of these last year. Number 2, correct each of the following statements. So that's just some theory in Pythagoras you should do. Number 3 is looking at working out the missing side using the theory of Pythagoras. So that's that. Number 4 gives you some diagrams. So here you need to solve for A, B, C, D, E, A, B, E, G, and H in the above diagrams. Okay, so that you're going to solve using this theory of Pythagoras again. So you have two sides. So if you look at number 4, okay, actually, I'm not going to go through it now. I want you guys to try it and see where you get. Okay, but the point is that you find a triangle with 2 of the sides given and work out the third side. That will allow you to get into the next triangle and the next triangle and so on. All right, guys, so what I want you to do is do 11.1 for homework. And then next video lecture, I'm going to continue. I'll go through maybe some of the harder ones of these, or I'll do one of these with you. And we'll move on to exercise 11.2 and the converse theorem of Pythagoras. Okay, so the converse theorem of Pythagoras is doing the theorem backwards. Okay, and I'll explain what we mean by that later on. All right, guys, I hope you enjoyed it, and good luck with the homework. Stay safe, and I'll see you next time.